Hi everyone. All right, so we're going to talk about distance formula and our shapes. So something we should have talked about this year is distance formula. So we're definitely going to talk about it now. So when you are transforming shapes or working with shapes on a coordinate plane, you can find the length of a side, or if you just have a line, you can find the length of what they call a line segment, which is just a dot line to another dot, and you can find that distance, you can find that measure. In order to do that, you're going to use the distance formula, which looks something like this. You will need two coordinates to do it. So let's say I have two coordinates, x and y. Similar to when we had slope, we need an x2, y2, and an x1, y1. So for distance formula, we have this square root symbol. And on the inside, we're going to take x2, subtract x1, and square it. And then we're going to add that to y2 minus y1 and square that as well. So remember when we were finding slope, slope was y2 minus y1 over x2 minus x1. That was one of the formulas that you needed to memorize for linear functions. All these right here, this x2, x1, y2, y1, they're just coordinates. You're taking these numbers and you're plugging them in and solving. So we're going to do that with shapes. All right, so we're going to do this first example together. So we have an example, a parallelogram with vertices of A, B, C, and D is reflected over a y-axis. And then we have part A and part B right here. So for first thing I need to do is I need to graph my pre-image, which is the parallelogram A, B, C, and D. So a parallelogram, if you don't remember or haven't seen it, parallelogram is just a special kind of quadrilateral. It's in the same family as rectangles and squares. So it's just a special name for a quadrilateral. And you're going to talk about more, you're going to do that more in geometry. So I want you to take this moment, I want you to graph on a coordinate plane your points A, B, C, and D. So there's my parallelogram, my quadrilateral A, B, C, and D. So then the next thing I need to take a look at is this is reflected over the y-axis. So that's telling me that I have to reflect my shape, which we just learned how to do. So I'm going to reflect over my y-axis. So if you remember, reflecting over the y-axis is moving left to right, which means your x values will change. Okay, so here, looking at A, B, C, and D, B is 2 spaces away from the origin, so when I flip it over, it also needs to be 2 spaces away from that same origin. So I'm going to plot my point at -2, 0 for B prime, and I'm going to do the same thing with C. So C is at 4, 2, which means when I flip it over my y-axis, it should be at -4, +2. Okay, so your x values here are changing, and the y values stay the same. So D is 2 spaces away, so I'm going to put D prime also 2 spaces away. So now the only thing that's a little different here is that A is on the y-axis, so A prime is also going to be on the y-axis. So once we have all of that information done, all the points plotted, we can connect our lines, and now we have our new image, A prime, B prime, C prime, and D prime. So then we can look at part A. So which vertex of the parallelogram will have the same x coordinate before and after the reflection? So this is a good question, just in, taking a look and observing what's happening. So which point is the same? Okay, which point has the same x coordinate before and after? Okay, and you should be telling me point A. Okay, point A and A prime are 0, 3. My x coordinate is this 0 right here. It did not change when we reflected it. So your answer for part A should be point A, so A prime and A, which is 0, 3. So then part B says find the lengths of all four sides. You're going to use this skill in geometry to prove that shapes are what they're asking. So we're just going to practice finding the distance with actual coordinates. So the first thing I want to do is I want to list what my A prime, B prime, C prime, and D prime are. So go ahead and do that now. List those points. So listed those points. We probably should have done that already, but we should have these points now: 0, 3, -2, 0, -4, 2, and -2, 5. I just want you to make sure you know which points you have. So the first thing we're going to do is we're going to find the distance from this A prime to B prime. So how I'm going to show this is I'm going to show A prime, B prime, and put a little line over it. And I'm going to put the distance equals, and then I'm going to do my formula. So if you remember, I'm just going to write my formula here. We should have it at the top of our notes. I'm going to write it down so I can use it for all of my other distances. So we need to decide here what we want our x1, y1, x2, and y2 to be. So I'm going to say A is 1 and B is 2. So when I plug in, it's going to be -2 minus 0 squared. Those are my x coordinates. Plus my 0, don't need the comma, minus 3, the whole thing squared. So I have my x's subtracting, and this is called the difference of x's and the difference of my y's. You're going to hear that, so you need to be familiar with that. So this little triangle x, triangle y means the change in or the difference of. So you'll use that terminology over the next few years. So then if I'm showing all my work, -2 minus 0 is just -2, and then we're going to square it. And then 0 minus 3 is -3, and we're going to square it. So we're going to keep going because we're finding the distance, we're finding the length. So -2 squared should give me 4, and -3 squared should give me 9. So I get this lovely radical of radical 13, and that's the measure. We're going to leave it just like that. We're not going to simplify it because this is the most exact answer. So for that yellow highlighted piece, it is root 13. Okay, so we're going to do this same stuff with our next segment. So I'm going to highlight that in green. So we're going to find the length of B prime, C prime. So I'll do that in orange over here. So B prime, C prime, the length of that. So the distance, you need to decide which one you want to be first and second. I'm just going to do B prime is 1 and C prime is 2. So my x value is -4 minus a -2, whole thing squared, plus 2, this is my y coordinates now, subtracting, whole thing squared. Okay? So then do your orders of operations. So this now minus a negative becomes plus. So -4 plus 2, I get -2 whole thing squared. And 2 minus 0 is a +2 whole thing squared. So now -2 squared is 4. +2 squared is 4. So I have root 8. So now we didn't simplify the last one because it couldn't be simplified. We are going to simplify this root 8. If you remember, it has factors of 4 and 2. 4 is a perfect square, so this becomes 2 root 2. And that's my answer for this green segment. Okay, so now we're going to do the same thing for the other two line segments. So I want you to go ahead and do that on your own. Okay, at this moment you should be doing these two segments on your own. So go ahead and do that. All right, so if you did the work for C prime, D prime, and A prime, D prime, those two segments, I highlighted them with the coordinating colors. You should get root 13 for the first one and 2 root 2 for the second one. So those are the distances, those are the lengths of those line segments of this parallelogram that we have. Okay, so that's how we would do it. It is a longer process. It does look a little scary because you're subtracting, squaring, and then square rooting. But as you practice, it'll get better. So let's take a look at this next example. We have a triangle that's shown in the grid, and Janet rotated it 90 degrees clockwise about the origin, creating a new image. So what are the coordinates of the vertices for the new image? And then we're going to find the lengths of those sides. So we're going to do a 90-degree rotation for the image that we have here. So the first thing, as always, we need to find our points for our pre-image. So go ahead and take a look at your graph and find those points. Okay, so if you found your points, you should have A at negative 4, 4, negative 2, 4 is B, and negative 2, let's fix that, negative 2, positive 1 is C. So now we're going to do a rotation of 90 degrees clockwise, so we can get our new A prime, B prime, and C prime, and get those new points. So a rotation that is 90 degrees clockwise, if you look at your notes, should be Y and then opposite X. So we're going to take our points and do that switching. So we should have Y, which is 4, and then opposite of negative 4 is a positive 4, and that's our new E prime. So if we went to our graph, A prime would be right up there. Same with B prime, Y is first, and then opposite X is a positive 2. So 4, 2, make sure you label your points, so that one's B prime. And then Y opposite X, we have 1, 2 for C prime. So now C prime is right there. So double check to make sure that you've plotted the points right. I just fixed B prime, so make sure you've plotted those correctly. So then our triangle looks like that. So then we need to find the lengths of all three sides. So again, to do that, we're going to use our distance formula, which is our x squared, or x2 minus x1 squared plus y2 minus y1 whole thing squared. So we're going to take our coordinates for our new image and find what those lengths are. You can see that, for like A prime, B prime, you could just count, and B prime to C prime, you could just count. But we're going to practice using the formula and then use counting to confirm that it's correct. Okay, so for A prime, B prime, so I have my distance, I'm going to use my new points. So, so if I have 4 minus 4, my x values, subtracting and then squared, and then my y values, 2 minus 4 whole thing squared. So now we should just have 0 plus 2 squared, or negative 2 squared, which gives us 4, which would end up square root of 4 is 2. And that's what that is. This is a length of 2 right here. So that's really good. So we're going to do the same thing. We're going to find the distance from B and C, or B prime to C prime, using the coordinates that we have. So we've got 1 minus 4 whole thing squared plus 2 minus 2 whole thing squared. So that gives us a negative 3 squared, and then it's a 0. So negative 3 squared is actually 9. Square root of 9 is 3, which is good because this length right here is 3. So it does match. So we are on the right track. We're almost done. The only one we can't find is, by counting, is AC, or A prime, C prime. They should be the exact same length. So this is where the distance formula comes in. So we're going to find that measure. Okay, so do your square root, and then we have, I'm going to do 1 minus 4, the whole thing squared for my x values, and then it'll be 2 minus 4 squared. Just make sure your order matches. If you start with C, the C coordinates, the x2, y2, then make sure you're not mixing and matching, just like when we did slope. So then this becomes negative 3 squared plus negative 2, the whole thing squared. So square root 9 plus 4. You can't do the square root of 9 and then do the square root of 4. You have to add them together. We've talked about that in class before. So this length right here should be the square root of 13. Okay, so you are adding them together and then doing your square root. Okay. All right, so now we've got some practice problems down here. All right, we got some practice problems down here. And I want you to try to tell me the lengths of the B, C, and CD on your own. And I want you to answer this question. Something we didn't talk about, when you've got something that means double prime, that means you've done two transformations. Okay, so we haven't talked about that, and I'm sure in a Zoom meeting we probably will. But if you have a double prime, it just means you've done two transformations. So you need to identify what transformation, and then you need to find the lengths of BC and CD using our distance formula. Okay, so there's that question there that you're going to answer. And then a rhombus is just essentially a special type of quadrilateral. So for this example right here, what you are going to do, you're going to find the perimeter, remember what perimeter is, of this ABCD, the rhombus. And that's it. Okay, have a good day.